Welcome, guys. Alright, we're going to continue talking about geometric sequences in this video. You've learned how to write the general formula for a geometric sequence and, well, how to find a common ratio and so forth. And now what you're going to do is you're going to use the general formula to find various information for a geometric sequence, similar to what we did with arithmetic sequences a couple of videos back. Alright, now, basically, I want to start this conversation off with this question right here. How many common ratios? And I did this with arithmetic sequences with how many common differences. And what I'm referring to is this. How many common ratios does it take to get from one term in a geometric sequence to another term? Now, for instance, you ought to know now that if you wanted to find the 8th term of a geometric sequence, that you would multiply the first term times the common ratio to the 7th power. Remember that exponent was always one less than the term number that you're trying to find. And so if you wanted to find the 11th term, that would be the first term times 10 common ratios, or times the common ratio 10 times. Alright, but you can also do this as well. You can go from one term to another. Let's say I wanted to know how many common ratios it took to get from the 17th term to the 20th term. All right, how many times would I have to multiply the 17th term by the common ratio in order to get to the 20th term? And you can simply find that out by finding the difference in the term numbers. Okay, if you're going from the 17th term to the 20th term, you're going to multiply by the common ratio to the 3rd power because that's the difference in the term numbers. Just like here, 8 minus 1 was 7. 11 minus 1 was 10. All right, so if I wanted to go from the 100 or to the 192nd term from the 115th term, I would just have to multiply the 115th term times the common ratio 77 times, r to the 77th power, because that's what 192 minus 115 is. All right, hopefully that makes sense. If you've got that down, then all of these problems that we're going to work with are going to be fairly simple. All right. In a geometric sequence, we're going to say that use of the 4th term, use of 4 is 3, and the 6th term, use of 6 is 27/16. And what I want us to do with that information is to be able to find the first term and the common ratio. In our previous video, you already knew the first term and you could find the common ratio to find another term. Now we're going to use other terms in the sequence to help us find the first term. And how are we going to do that? Well, let's use that same logic that I was just talking about on the previous slide. Let's make a relationship between the 4th term and the 6th term, and that relationship is that if you wanted to calculate the 6th term using the 4th term, you would have to multiply the 4th term times the common ratio twice. Okay, so u to the 4th times r is what I mean. We'll get you u to the 6th power. Now with that in mind, and knowing that u to the 6th term is 3, the 4th term is 3, the 6th term is 27/16. We have an equation that we can use to find out what the common ratio is. Alright, now what I'm going to do is I'm going to multiply both sides by 1/3 to cancel out this 3. And if I multiply 27/16 by 1/3, it's going to give me 9/16. And here's an interesting thing for geometric sequences. This couldn't happen with arithmetic sequences. Geometric sequences you can sometimes have two different common ratios, get a positive or negative common ratio, with any pairs of terms that you're given. In this case, you see how if r squared is equal to 9/16, that r could either be positive 3/4 or negative 3/4. But for the purposes of this problem, I told us to assume that the common ratio is negative. So when we take the square root of both sides, we're going to say that r is equal to 3/4. Alright, so that's the common ratio. That's one of our two responses here. We still need to find out what the first term is. And we can find out what the first term is by using either the 4th term or the 6th term. It doesn't matter. We just have to make a relationship between one of those and the first term. So let's do that. Let's use the 4th term. The 4th term is equal to the first term times the common ratio to the 3rd power, right? So 3 equals u sub 1 times 3/4 cubed. All right, now a couple steps to getting u1 by itself here, u sub 1 by itself. Let's go ahead and cube the 3/4, and that's going to give us 27/16. And then we're going to multiply both sides by the reciprocal of 27/16. So that means we're going to have 3 times 16 divided by 27. 3 times 16 is 48. And we'll have over 27. And we'll just simplify that. These are both divisible by 3. Anything bigger than that? Nope, just 3. So 16/9 is the value of the first term in this sequence. There we go. If you understood that, oh no, this is a whole different question. Now we're going to try to find the value of x if we know two terms and we're trying to find the value of the term that's between them. Now how might we go about this? Well, knowing that it's a geometric sequence, which this problem tells us, we know that there is a common ratio between the terms, correct? And remember, you can find the common ratio by making a ratio out of any two consecutive terms. That's what I'm going to do right here. I'm going to make a ratio out of the second term with the first term, and that's going to have to be equal to the ratio of the third term with the second term, just because of that common ratio thing. And so using that idea of the common ratio, we're going to be able to find out what that term in the middle is by solving this proportion. Alright, cross multiply, you're going to get x squared equals 324. And this time, I didn't say that this number had to be positive or had to be negative, and so we're going to take the positive and negative square root of both sides. We're going to say x can be equal either positive 18 or negative 18. And I want to show you that that works no matter which value that you pick. If we picked positive 18, then we would have the sequence 12, positive 18, and positive 27. And 18 over 12 is equal to 27 over 18. They're both equal to 3/2. Whereas if I had picked the negative value, the sequence would be 12, negative 18, 27. All right, you see how the common ratio is just going to be different. Now we're just multiplying every term by a negative value, but the 12 and the 27 would still be 12 and 27. All right, in this case, the common ratio would have been negative 3/2 instead of positive 3/2, and that's completely fine. Okay, so you try the same thing with the second example there. And here's how that should look. You should have made a ratio of x over 48 equals 3 over x, which gives you x squared equals 144. So x equals positive or negative 12. All right, now we're going to work with the same kind of problem, but switch it up slightly. Still wanting you to find, same directions, still want you to find the value of x for each geometric sequence. It's just that now I didn't give you the first and the last term. Each of the three terms is a variable. But we're going to set it up the same way. Now I'd like you to try this once we set it up on your own, actually try the solving. We'll make a ratio of the second term to the first term. And set that equal to the ratio of the third term to the second term. Now when you cross multiply, you're going to end up with a quadratic equation. And it turns out to be one that you can factor. I'll let you know that in advance, but if you prefer to use quadratic formula to solve it, feel free to do so. Just make sure you set everything equal to 0. I would like you to try that again before you watch the solution. So pause the video and do that, please. Alright, so here's the work then. We're going to end up with 2x plus 16 squared whenever we multiply those two things together, the extremes. Then we multiply the means, 2x and 3x plus 4. Well, alright, there we go. We're going to set those things equal to one another. Now, to square 2x plus 16, we're going to end up with 4x squared plus 64x plus 256. And that'll equal 6x squared plus 8x. And I'm going to try to bring everything over to the right side of the equation because the x squareds are larger over there. So we'll subtract everything on the left side of the equation and make that side 0. 6x squared minus 4x squared is going to give you 2x squared. 8x minus 64x is negative 56x. And then we'll subtract 256. And last thing I'll do before I'll factor, which I told you was possible here, go ahead and divide every term by 2 just to make the numbers a little bit easier, since they are all even numbers. We have x squared minus 28x minus 128. Alright, and now we got to figure out then the factors of negative 128 that add up to negative 28, and it turns out that those factors are negative 32 and positive 4. So x minus 32 times x plus 4 equals 0, meaning that you're going to get x equals 32 and x equals negative 4 for your solutions. Now, as always, I'd like you to see that what you're doing is working. So I'm going to show you up here really quickly, like if x equals negative 4, what the sequence is, and then if x equals 32, just so you know that those totally different answers both make geometric sequences. Alright, so if x is equal to negative 4, then you're going to have negative 12 plus 4, or negative 8 for the first term. Then you'd have negative 8 plus 16, or positive 8 for the second term. And you'd have 2 times negative 4, so negative 8 for the third term. So that would be a geometric sequence in which the common ratio is negative 1. Then if we let x equal 32, then you have 96 plus 4, or 100 for the first term. You would have 64 plus 16, or 80 for the second term. And you'd have 2 times 32, 64 for the third term. Now, the common ratio in that case would be 0.8. Alright, if you multiply 100 by 0.8, you get 80. If you multiply 80 by 0.8, you get 64. So 2 different geometric sequences. Alright, so that's a way of using the common ratio as well as the general formula for geometric sequences in order to answer other questions about geometric sequences. Alright guys, see you next time.